Today we're going to talk about the inverse function of e to the x, which is natural log of x. I like to call it ln x, but other people call it different things. So you'll hear me call it natural log, or you'll hear me call it ln. Either way, the derivative of this function, ln x, is just 1 over x. Alright, and so the derivative of the ln of something will be 1 over that something times the derivative of that something if we're doing chain rule. Alright, so let's do an example, which is a little more complicated than just asking you for the derivative of ln x. So let's see what we have here. I have ln of x to the 5th plus 4x cubed plus the ln of x to the 4th plus 7 plus the ln of 2x plus 8 cubed. So let's do this one step at a time. Let's start with this function. The derivative of the ln of something is 1 over that something, which is x to the 5th plus 4x cubed. That takes care of the ln part. And then the derivative of the x to the 5th plus 4x cubed is 5x to the 4th plus 12x squared. And let's just put that in parentheses. Plus the ln of x to the 4th plus 7. Well, ln is the outside function. So the ln of x to the 4th plus 7, the derivative of that is 1 over x to the 4th plus 7 times the derivative of x to the 4th plus 7, which is just 4x cubed. And then in this first term, or this third term, I've got 3 functions, and the very outside one would be this cubic. So the derivative of something cubed is 3 times that something squared. So it's the ln of 2x plus 8 squared, and that's multiplied by 3. And that gets multiplied by the derivative of the ln of something, which is 1 over 2x plus 8. And then that gets multiplied by the derivative of 2x plus 8, which is 2. So hopefully everything down here matches. It's unsimplified, so let me just move all these other polynomials to the top of the fractions. And it would simplify to something like that. And the last thing I notice is that the first fraction has at least an x squared in all of these terms, so I just factored that out, and all of the exponents of x reduced by 2. And that would be your answer, nice and cleaned up. Alright, so that is just an example. If you want to see the proof, then you can keep watching. If you're not interested in the proof, then you can stop right here. So here's our proof for those that want to see it. Y equals the natural log of x. So what I'm going to do, since I already know how to find the derivative of e to the x, which I did in the last video, I'm going to change this function so that instead of y depending on x, x depends on y. X is a function of y. So I can find dx dy. And if x is e to the y, well then the derivative of x is the same thing, e to the y. Alright? And then to switch this to dy dx, I just flip it upside down, which means I would flip the right-hand side upside down as well. So instead of it being e to the y over 1, it's 1 over e to the y. Well, e to the y is also known as x. So dy dx is 1 over x. So it's a nice simple proof, but I needed to know the proof for the derivative of e to the x first in order for me to do that. Alright, so that's it for today, and email me if you have questions, and we'll see you tomorrow.